About 30 hours ago, the Foundation Society issued us all with a challenge. It's a lunar base, it's in lava tubes, there's a lot more specifics after that. But after all, 30 hours later, here we are. Ladies and gentlemen, I'm Will Stewart. I'm the CEO for Crux, a subsidiary of Brumbo Aerospace, and this is Alexander Roll. Of course, if you couldn't guess, it's named after Alexander the Great, a conqueror, an adventurer, and in my opinion, a guy who's really good at making networks. So again, this is the sort of thing we want. Our envision of this is to be both a marriage of the requirements of the Foundation Society and the signature innovation of Crux Company. Without further ado, I'd like to introduce our CFO, Elizabeth Fisher, to go through the ins and outs of business with Alexander Roll.
Alexander Roll is a design that is incredibly innovative, putting an emphasis on the flexibility of the base. F1MA robots are used to easily remodel the well-used casks into retrofitted designs as the clients require into whatever module is needed. This is incredibly useful as a Foundation Society would be able to maximize the efficiency of the base as a presence on the moon, especially according to research demands. Furthermore, as Alexander Roll will be the sole provider of research sites on the moon, the client would be able to gain a lucrative earning from the renting of research facilities to multiple private corporations. This is estimated to provide an annual revenue of at least $12 billion over 4 research facilities. Thus, we would expect to break even with the first 10 years of the contract award and earn the first $1 billion within the next year. The costs for each department are broken down in the following 2 slides, where the annual costs, aside from the human employees, are for maintenance. We can calculate from this information that the total annual cost of Alexander Roll is $1.1 billion. Phase 1 of construction has a construction cost of $385 million, Phase 2, $236 million, Phase 3, $197 million, Phase 4, $510 million, Phase 5, $197 million, and Phase 6, $224 million. The Gantt chart shown above demonstrates the timeframes of each major stage of operation of Alexander Roll. As you can see, the construction of the station will be complete within 6 years of the contract award. In order to maximize the efficiency of construction, the F1MA robots used to build the communication system in Phase 1 will build docking ports with human supervision in Phase 2 and 3 in order to receive greater amounts of supplies, thus expediting the construction processes for the next phases. Beyond the extent of the Gantt chart, the processes of maintaining the agricultural systems will continue. While there are many advantages to building bases on the moon, some risks to settlement have been identified. The most severe of these risks is the threat of moonquakes. This will be managed with the technology of friction pendulum bearings that allow the structures to move side to side while staying stable, ensuring no habitats or research facilities collapse. Some great opportunities for the Alexander Roll, however, have also been identified. The most beneficial being the astronomy research that is possible from the moon. The lack of atmosphere and the long hours of darkness are an asset as it allows optimum long-term viewing of distant objects. Another opportunity available is the use of research rovers to collect information about resources found on the moon, which may be useful to support future mining of the moon's surface. I would introduce Locke-Blair's structure.
To fully utilize the recyclable intent of the cassix, an initial base is constructed in the shape of an octagon within a lava tube. Each side is capable of holding 5 of the cassix systems wide and 2 high, for a total of 10 per panel. The initial structure is repeated 3 times, with the first 2 being able to hold 60 cassix each, with the last structure capable of holding an extra 10 on the unused panel. This allows for a total of 190 cassix modules to be utilized by the settlement. Alternate uses of the cassix include pathways between habitats. Here you can see the proposed dimensions of our settlement, which have standardized measurements that are greatly influenced by the size of the cassix, which we are using for the majority of our living and infrastructure quarters. The settlement will be raised up off the surface of the lava tube with a series of rigid and stable support pillars, which will bear the full load of the internal octagon structures. To counteract the issue of lunar quakes, the bottom of the pillars will utilize friction pendulum bearings, which are an earthquake mitigation system already in use on Earth. These are shown here, up in the top right corner, and work by allowing the whole structure to move slightly on its columns, counteracting the vibrations caused by the quakes. We chose to use tungsten within the bearings to deal with any possible heat caused by the lunar quakes of longer duration, and the resistant nature of the tungsten will ensure the friction bearings will remain stable. The most prominent material composition is that of the cassock. The walls will be constructed out of anodized steel and low-grade polyurethane. The low-grade nature of the polyurethane will allow the settlement to have some flexibility during a lunar quake event or an explosive decompressurization. This will thus ensure the overall integrity of the structure. We have our interior layout focused prominently on the cassock's provided space, and you can see our percentage use up there as well. There is a 6-phase construction sequence, including variable ports at phase 4 for all sized vehicles, yet maintaining a constant offload size due to the craft offloading the cassock's constant size. Our research bases will utilize the cassocks attached to another center structure. The research bases will be placed inside lava tubes with several potential spots already plotted out there. Pressurized and unpressurized zones are provided for a range of tests to be conducted with airlocks connecting to the cassocks to the base. Well, I'd like to hand over to our next presenter.
Here we have the machinery that will be utilized on the base. This table also includes the purposes and how the machines will be sourced. On this slide, we have all the materials used in the construction of the settlement, the amounts, and from where they will also be sourced. On this slide, we will have the atmospheric pressure and composition of alexandrol, as well as the process of purification. The composition will be 77% nitrogen, 23% oxygen, and less than 1% carbon dioxide. Also on this side are the heating and cooling systems for the station, which will be done by using a combination of water cooling and external radiators. Here we have the dust mitigation, utilizing a magnetic filter to attract lunar dust, which contains iron, allowing it to be collected. These will be located at 0.5 kilometer intervals along the transport routes, in addition to the airlock. The main form of external communication on Alexandril will be through Li-Fi satellite technology with a backup Wi-Fi connect. Everyone will also be issued with a smartwatch for security, identification, and more. This slide contains the agriculture information, and we'll be utilizing a Garden and Go-Go subcontractors to build 40 self-contained dual hydroponics and rabbit hutch or chicken coop, which will provide the workers both meat, eggs, and assorted crops. The main external transport will be the lunar rover, which can carry 8 people around the surface. Also on this page is a table showing the total energy consumption for the base daily, yearly, and per person per vehicle. Here we have the water and waste recycling process, as well as the pipelines for the water and the waste. We'll have 13 casks of water circulating every year, which will need to be topped up with 1 cask annually. On this slide, we have the trade-off study and information on our energy concept. In this slide, options for a ground solar panel farm and a satellite transmission method were weighed against each other, with our settlement coming to the conclusion that the ground panels would be ideal for our base. We encountered the issue of having 14 days of darkness on the moon, and we are solving this issue by using a lightwork subcontractor, allowing the solar farm to run during the 14 days of no sun. This is the Seek transport. Is provided by Grumbo, our parent company. This allows for us to integrate with other machines, making a hive mind. The Seek can transport 4 casks at a time, and has 8 wheels made of a mesh for maximum stability, which helps during lunar quakes and terrain driving. In the port itself, there are 6 launch pads and 3 routes. This is to ensure traffic flow and as fast as possible loading. If there's an explosion, the 3 routes mean nothing will be compromised. The port and the Seek will also have electrodynamic shields that repels lunar dust away from sensitive infrastructure. I'll pass you on to final.
Yes, Will. Yes. Okay. As part of the intended experience for Alexandrol's residents, the community design has been made so to reflect core values of efficiency, safety, and comfort. As such, in conjunction with the viewing port as previously seen in structure, the community and housing designs have been designed with a balance of space and cost efficiency in mind. Featuring an octagonal base module with cask-based housing units, this mapping and layout system can be easily replicated for future application and growth of Alexandrol. Our housing designs, consisting of 2 casks connected vertically, is designed to fit 6 employees, each with a private ensuite and bathroom, as well as a communal dining and living area on the first floor, along with a compact staircase connecting these 3 divided stories. As you can see in 3D and side-on views of our planned housing units, along with the concepts for customizable storage that can be used for any imaginable household purpose. In terms of consumables, aside from basics of residential health, Crux intends to provide each resident with access to sanitary kits, clothing, and as an addition to psychological health, a simulation window. This would exploit the growing 21st century trend of VR technology, and by being able to track a resident's eye movement throughout the room, it can simulate a 3D environment. This effectively reduces the risk for claustrophobia within residents. Additionally, residents' needs for consumables are distributed by automation. Outside of the standard workplace health and safety, the added risks of low gravity, lunar dust, and extreme radiation exposure have been effectively mitigated, as seen here. Upon return to Earth, employees having undergone the daily exercise expected to maintain bone density, and of course the other downsides to low gravity existence, will largely avoid the issues of atrophy, physical or otherwise. Another usage for cask models following cargo is as an emergency medical bay or isolation ward in case of an infection outbreak. Furthermore, the sociological environment of Alexanderol will be maintained via constant but non-invasive monitoring of all staff and occupants, making sure that we stop the problem before it becomes a problem. In the event of any emergencies, be it injury, illness, chronic fatigue, the clinical system available on-site will be able to counteract and stabilize residents, and, if need be, intervention via surgical equipment can be controlled from Earth via link. One of the primary concerns outlined by the Foundation Society and recognized by Crux is dust mitigation. As such, multiple decontamination and electrodynamic dust shielding, as can be seen here, can stop the vast hazards that can be expected from dust. Furthermore, our magnets can be reverse polarity, as, of course, the lunar dust can change polarity over time depending on geological and weather effects. Again, you can also see the display PPE and contingencies considered by Crux within both research facilities and general communities. In the event of any disruption to wireless communication, hardwired lighting systems will be able to help guide residents to safe areas. I would now like to pass you over to our final department with Jared Fuller.
Crux's automation department will largely use the F1M8 robots accessible from our parent company, Grumbo. These modular robots will be able to be customized to any task with different arm attachments, including the ability to remodel a cask to suit any purpose. To prevent dust from grinding down moving components of the machine, tracks or wheels will not be used. Instead, F1M8 robots will have 8 legs for easy movement and balance. These will be covered in synthetic tarsal claws, mirroring the hairs on a spider's legs. These will allow for greater access to F1M8s as they'll be able to climb on all surfaces. F1M8s, using their HiveMind AI, will construct preliminary buildings at the base before humans arrive to oversee the rest of construction. Aside from F1M8s, Alexanderol will have kitchen robots for cooking, serving, and cleaning, as well as Explorer rovers on the lunar surface. Robots will be constantly monitored for performance with daily cleaning from lunar dust. The HiveMind AI of the F1M8s allows them to perform maintenance on themselves and other robots, meaning problems with automated devices will be incredibly rare. All automated systems in Alexanderol will have a designated level of security befitting the sensitivity of information that can be accessed, with 4 different sign-in measures as seen above. Crux have planned for every plausible contingency on Alexanderol, creating processes to follow in order to minimize damage in these events. It is the aim of this company to have no loss of equipment, personnel, or operations in the event of microbial outbreak, fire, moonquake, or disruption in supply missions. Sensors can detect rapid depressurization and shut down the affected zones immediately for repair. If these sensors also detect slow loss of pressure, the area will be evacuated before being sealed and repaired. In the event of a solar flare, external communications and infrastructure will be retracted into safe shelter and shielded from any damage, and robots will be returned to base for protection. For the duration of a solar event, operations will remain as normal inside Alexanderol. To keep operations smooth in Alexanderol, a control hub will oversee all automated processes to ensure AI is operating as intended. This control hub also contains space traffic control for the port facilities with full human control. Crux believe that human oversight is important when so much of Alexander's operations rely on automation to ensure proper and smooth operations. In the event of this hub being offline, a secondary facility is located in the lava tube for use of the exact same systems and safety. Thank you very much.
As part of Alexander Role, we are meeting the Foundation Society's need for exploration with Crux's innovation. We'd like to appreciate the consideration from the judge panel, and we hope that you enjoyed our presentation. Thank you.